Hello, hello. So my talk will not be about performance. It will not be about scale because I come from Belgium. And basically in Belgium, we have nothing at a very huge scale. My story will be about how we use all the features that HAProxy can provide us to achieve exactly what we need to achieve. So, setting up the scene. So, this is about using HAProxy to send requests to the outside world. So usually what you do is you put HAProxy at the beginning of your infrastructure, and then you let the traffic going in. What we want to do is actually to go out to the internet, to some private lines, to actually make a HTTP request from HAProxy. It means that the client will be HAProxy, and we will offload a lot of things to HAProxy itself. Like, for example, retrying requests that might fail, or throttling requests, which means that if a partner is getting slow, then we don't want to continue sending it request and request. We want maybe to say for that partner, we only send a limited number of requests at the same time, so we don't overload our own applications. So this is about a message broker in Belgium. So basically, we have a lot of different partners that we need to send messages to. The difference between healthcare services and other kind of thing is that more often you want the transaction to arrive at the other end, and you don't care that much about performance. So for us, it was more important that we knew that the transaction was successful than it was done in a few milliseconds. With HAProxy, we get both, so we are quite happy with that. We also have a lot of services, and it means that we have some new ones that are a few months old, but we also have some services that are 10, 20 years old that are still running and that are still doing some kind of business. So we still need to maintain all that stack from very old and very new technologies. And another thing that's important is that we do mainly SOAP and REST API, so it's not about that we don't need to do a lot of followings on the HTTP request. We only get straightforward URLs that we know in advance, so it makes our job quite easy because of those very old technologies that don't change that much. So one of the challenges that we had and that actually forced us to find a solution was that, at some point you want to migrate your TLS version. At some point you want to use SNI. And guess what? 10 years old, 20 years old technologies cannot do that kind of things. You cannot suddenly take a very old stack and say, now we use TLS 1.2. If that technology didn't even know about what's TLS or what was TLS version 1.0. So we wanted to get a way to get that moving and to still be able to move forward with those very old applications. So we wanted to find a way to do this, to talk to the latest technologies, to the outside world. And we wanted that to be quite easy, so we didn't want to spend a lot of time developing application, developing stuff, developing I don't know which kind of service mesh. We wanted something that would bring us quite easily forward. So how does it look like? So basically, we have a bunch of applications in different VLANs, and they will all talk to an HAProxy server, or a cluster of HAProxy servers. And that HAProxy server will be responsible to talking to the internet or to a lot of private lines. So it's very important, so I mentioned private lines explicitly, because when you talk to the internet, there are some rules, like you have a DNS name, like you have that kind of things. When you use private lines, people think they can decide whatever they want, and we have some kind of crazy stuff going there. But it's not the internet, so we can do whatever we want. But the application don't have access to the internet directly, so there is no escape path. You must use HAProxy to connect to the partners. So One last point that I want to mention is why we did not get a normal HTTPS proxy. So the issue with the normal HTTPS proxies is that they will just open a TCP socket between you and the target, and you are still responsible for everything that's in the middle. So maybe they can redo the TCP connection if that fails, but they will not be able to do any much more. And we wanted to do something better than that, so we wanted the proxy to know about the request and to really be able to do the TLS negotiation and all that stuff, which is not possible with a normal HTTPS proxy. So instead, we have HAProxy, so we are actually doing our HTTPS connections to the HAProxy server, and it will do the final request to the outside world. So that's how we started to use it. So basically, HAProxy is terminating a TLS connection and starting a new one. So the way that you should use, that we use HAProxy is that instead of calling a URL called example.com, you actually call the internal proxy. It means that for the application itself, it's not using a proxy at all. It is just like calling our proxy with a slightly longer URL than you would expect. But we do it so that we can identify a lot of things in that URL. We actually have a web page that will enable application owner to decide which URL they need to use. So if we look at that URL more deeply, what do we find? So my application, my back, will call a long application, but we can actually split that application in multiple parts. So if we look a bit further, we'll see that the new URL is proxy.news.eu / then the name of the application, then the name of the partner, then a bunch of other stuff. So basically, we can identify in the new URL that we pass to HAProxy to the application that is calling the HAProxy. So it means that when you look at the HAProxy logs, you will directly see which application it is. Because we have a lot of applications on the same machine, the IP is not sufficient enough to know which application is calling which URL, and it's possible that multiple applications will call the same URL. So getting the application is very useful. Then you get the partner. So we have like dozens of different partners. They have different behaviors, and they have different applications as well. So we define the partner that you want to call using the HAProxy. So we only have one HAProxy frontend, and in the URL we define the partner that we want to call, the environment and the application and the partner that we want to call. Then we have something that's called the SLA. So what we call the SLA is actually just timeouts, because we do a lot of business. Some of them is like synchronous business, like you expect a reply now, and other thing is like posting a 1 GB file to the other direction, or putting like a file of 10, 20 megabytes. And for that, you don't have the same timeouts as previously. And then you have the rest of the URL, because like in one application, you will have multiple endpoints behind that URL. So by looking at that, we already know a lot about the request that the application is trying to perform. So if I take back my URL that you have seen, that was very long, actually I can now read it, and I know that the application my back in production is calling the URL / hello world of the service www, the partner example in production, and that we expect quite a quick answer from that partner. Actually, the reason why we have timeout is so that every application that we have will now follow the same rules. And we don't need to define in each application what should be the timeout, what should be. We define that in the HAProxy, and basically HAProxy will do the work for us to define what will be the timeout, the same timeouts for such services. And now if you can read one of those URLs, you can actually read all of them. So if I show you now another URL, well, maybe not now, but if you're used to it, you can now know exactly what do those URL means. So first remark, so when you migrate to calling directly your partners using HTTPS to the outside world, then you also, when you migrate to HAProxy, use HTTPS so that you don't have more unencrypted traffic after you move than before you move. the second thing is that the application, we need to change the URL in the applications. So it's not like a flag that you pass to the application. We really need to adapt the applications, but that will provide us a lot of benefits. And also, as you have seen, we have two HTTPS connections, which means that internally we can still allow TLS 1.1, 1.0, but to the outside world, we will actually use TLS 1.2, so the best that HAProxy can do to the partners. So let's talk a bit about access control, because now that you have a central HAProxy, you want to avoid mistakes or to get a bit of, to play a bit with the HAProxy ACLs, right? So we have a very basic access control right now, which is just IP-based, which you cannot really call security, but it prevents a lot of mistakes at least. And so that's the first access control that we have in place. So just a bunch of clients with a name and an environment. So the HAProxy that we use, basically we have two clusters, one for production, one for non-production, and we have a bunch of ACLs that will tell us, okay, that application can come from that IP range. So then we actually, for each one of the application, we actually have another ACL that will look for the path of the URL. So we use the pathback directive in HAProxy to say, okay, if the path is beginning with that URL like myback prod example prod wwi, then I will use the use backend directive to say, okay, for that specific, if those conditions are met, so in this case it will be that the application matches my client, that the IP matches my client, and that the path is beginning with what my client should announce, then you will use that backend. It means that for one front end, we'll use multiple backends depending on each one of the requests that we have. So we don't have like 1,000 different front ends we wrote based on the URI that we get, and only if the client is recognized, the client's IP is recognized. So you might notice also that the backend is not per client. It means that if we have a partner called by multiple clients, they will all use the same backend, so they will all use the same pools. So for now, so that we have identified the client based on its IP and the URL that it is calling, and HAProxy will actually validate that it is a client that's expected to come from that IP. And basically, we have everything in the URL, right? And we also have some SLA that tells us, okay, we want or not to send the request with a large or long timeout. So for now on, we have used quite some features of HAProxy, like passback and use backend. Just know that the backend is just an external partner and not something that we own internally, right? So SLAs, well, what we called SLAs. So basically, we set the SLAs for each one of the backends, yeah. And basically, it can vary from like a few seconds to several minutes. And it's not really practical to do it for each application. Well, you can do it if you have a unified stack or just 2 or 3 technologies, but you actually have a lot of technologies over time. So just taking those SLAs at the HAProxy level and having them just on the URI helps us a lot, just knowing what will be the timeout that the application will use or will not use. So that's what we have. So we have some SLAs that are like when we post big files, that will be like maybe like 5 minutes. And also some medium SLAs for like normal transaction that will go up to 30 seconds. And the lowest SLA that we have is like 10 seconds. So we are not in a hurry, right? Some very specific application can get some specific SLAs as well. So sometimes we time out after 3 seconds, and sometimes a bit more. So we have really like a long range of SLAs that are possible for the application owners at the HAProxy level. So basically, that's what it looks one SLA. So basically, we set the different timers. One thing that's common is that we don't want to queue requests at the HAProxy level. It means that if a partner is responding slowly, and then we fill the number of connections that we have set for that partner, then HAProxy will return directly for the next request saying, hey, I can do it now. So the problem with what we have seen now is that basically the request that we make to the HAProxy is not the request that we want to send to the outside world, right? I mean, if I contact a partner and that my URL is full of all those identifying stuff that we have put at the beginning, that's not going to make it correctly. So basically, because HAProxy isn't a forward proxy, it will not actually, it will by default just pass my request like it is now, like with all that big path that we want. So we will change the request, and we'll make it look like it's actually a request made for the backend that we want to address. So what do you need to change from that request to make it like a real request? So the first thing is that you will want to change the hostname header, right? Because now the header will be like proxy.inuits.eu. The host header is not correct, because in this case, you would expect it to be like example.com. SNI. So SNI is when you initiate a TLS connection, you can specify which certificate you want to retrieve by adding a specific SNI attribute to the connection so that you know, hey, this is the server name that I expect to see. And basically, you need to tell HAProxy which SNI you want to use. And the last thing is that we will need to do something with that /mybackprod and remove it to only keep the part that is actually interesting us, which is the /hello world. So this is how we actually alter the query. So HAProxy is full of a lot of different functions that you can use to alter your requests. And in this case, we will first set the header host to www.example.com. For that specific backend, it means that it will remove the existing host header, and it will just set it to example.com. And then we set the SNI in the server part. So basically, we use the str function, which takes a string as input, and then you can just specify the SNI that you want to use. So by doing those two things, it is just like the request was sent for example.com at the beginning. Then we defined the example.com using its DNS name, because as we call the outside world, we don't want to hardcode the IP addresses all the time. We don't want to put a monitoring to say, oh, did the IP change? So we are just using DNS resolution. So you can see resolvers my DNS, and in our case, we actually use a lot of IPv4. So in this case, we also say, OK, we prefer IPv4 if you offer both of them. And then there is that rec rep line. What it will do is that, so the rec rep will replace the request line in HTTP. And basically, what the request line will contain is like the method that you are using, like post, get, put, delete options, and then the URI, and then the HTTP version. So in our case, we are interested to keep the method, of course. So we want to keep the get, post, etc. And then we want to just remove the client and the environment of the client, and then the example prod WWI, which are the other attributes that we set in the URI from the application. So basically, we take the first and the last thing on that request line, and that makes the new query, right? So that makes the new first line of the query. We are also using, so for the SSL, in this case, we are also using the certificate file provided by our distribution to validate the backends, so the partner's certificate. So that's for the backend part. OK, so that's what I just explained. Again. So now we have used a bunch of more HAProxy features that you don't always use when you want to do just load balancing. So recrep will enable you to alter the request line and change the URI on the fly. Set header will just like set a header or add it if it's not there yet. The str function, very useful when you want to work with strings. So if you, the first time you try it, you just put like the string itself, it's not working. So you find the str function, which is really useful. And then SNI enables you to, when you do the SSL connection, to put the SNI information. So DNS. Remember when I mentioned about private lines, that kind of things? So that's my backend. And basically, I had resolver my DNS inside the backend. And then we define a bunch of different options and timeouts to the backend, to the DNS information. There is something that you should know about HAProxy if you start using DNS, is that at least in 1.8, when HAProxy will start and validate the configuration, it will not use that section. So what it will do, it will try to resolve the host using the operating system DNS. And then only 5 minutes after, well, when that timeout is set, then it will actually try to resolve the actual backend DNS name, which means that you can have an HAProxy that will reload correctly because it is using the operating system DNS, and then 5 minutes later, the DNS server that you have in the configuration there will make all the requests fail because they don't have the correct DNS entries. So I agree that ideally you should have the same in the operating system and the HAProxy, but sometimes we didn't have that. So that's the DNS section. Also, when the DNS resolution is failing, the error message in the log is not like quite crystal clear, so sometimes it took us some time to figure out what was going on. So in the real world, we have some strange things. Like sometimes the partners, they just don't publish the DNS entries. Why would they publish a DNS entry? Yeah, you know, or not yet. So we had sometimes partners that say, yeah, we will put that new service up like in 10 days, and then you will need to switch to that URL, and then you ask, okay, but we cannot resolve that yet. And they say, yeah, when you can resolve it, then the service will be up. So that's like not really helpful for us because we like to prepare stuff in advance, right? Or we also have some partners that, don't ask me why, they decide that the production and the non-production will have the same host name, but different IP addresses. So this is very inconvenient for you. So what you used to do is like changing the host file but that's really a mess. So we don't know why that happens, but basically it's a use case that we used to support for like 10 years. So now we need to say, okay, we will support it, yeah. So that's very easy, actually, the no DNS scenario, because all you need to do is just to put the IP address as the backend. And it means that HAProxy, because we have the SNI and the HTTP request directive in the file, it will be completely transparent for the backend if we did use DNS or not. So in those cases, that makes our life really, really easy. And we don't need to change the etc host file on all the different hosts because HAProxy is clever enough to just do all the work for us. And if we have different backend with different IP but the same host name, there is no issue for HAProxy with that because they are completely independent. And that's really, really great. So some advanced topics that we have. So now that we have all of that thing in place, what can we do more? What can HAProxy bring us more than what we had in the past? So we can do like canary releases. Like we have a partner that will tell us, yeah, we want to try a new service or we have something new that we would like to try. And basically we can just change the path of the request when HAProxy is treating them so that if you put that first, then if the condition like when 100 is less than 10, then 10% of the request will go to the new service. So we do it just by changing the path of the request, and because we have all the other ACLs that will check for that path, then it will actually enable us to switch to the new service in 10% of the cases, which is really convenient, and which we can do just on the top of the configuration file, and we can actually do some, we can also do that for other advanced topics, like, in this case, we have a partner that informs us, hey, by the way, on Sunday at 10 a.m., we will work, so please, at that moment, exactly change your HAProxy, well, your URL to point to the new URL, because we will like switch data center, switch service. And we were like, do we really want to like work at 10 a.m. on Sunday just to make sure that the partners will be happy that we call the new URL? So instead of that, we actually use the date function in HAProxy, which means that just at Sunday at 10 a.m., at that moment exactly, we knew that we would use the new service at the partner. And no one needed to like wake up on Sunday or work on Sunday. It was just all done magically via HAProxy. And this is actually really, really great because you can actually plan the changes in advance, you can plan the rollouts, you can plan a bunch of stuff with that date function that before was like quite painful because you had no other solution that like, okay, we will restart all the different applications on Sunday at 10 a.m. just to change the URL. Now we do all the work at the HAProxy level, and it is clever enough just to do it just when we want it to do it. We also have some partners to which we need to talk with client-side certificate, which I don't know who would use that internally, but I mean, we can do it nicely with HAProxy. There is a CRT directive that enables us to like talk to partners using a client SSL certificate. And we also have another partner which is like, I want to make sure that you use TLS 1.2. And how do you do that? Well, you have a nice first TLS v1.2 in the configuration. I've seen that in the latest release, you also have first TLS 1.3. So basically, it makes sure that HAProxy will only talk TLS 1.2 to the partner. So you can tell them, OK, no, if you roll back to TLS 1.0 and disable TLS 1.2, we won't talk to you anymore, but you ask for it, you have it, right? So let's take a look now at the setup and the maintenance of all that setup that we have with HAProxy. So basically, we have quite a big file. So we have like 5,000 lines of configuration. So that's the point when we are happy not to have a big scale or a lot of like hundreds of partners, because like we have, I think the file is quite nice. But what's important is that for the application owners, for the people that need to connect to the proxy, it's very easy for them. Because all they need to tell us is who will be the client, who will be the partners, and which kind of SLA do they want us to configure. And basically, that's like 3 simple YAML files with a couple of lines for each entry, and then we turn that into that gigantic HAProxy configuration using Ansible. So it means that we have an abstraction between that big HAProxy configuration that will actually enable us to remove a lot of mistakes that you can do, or that you can also like make a lot of strange things. So basically, we know in advance which kind of input we can get from the application maintainers, and we can basically abstract that nicely. And it also means that our developers, they don't need to know everything about HAProxy. They don't need to know about the configuration. They don't need to know anything. From them, it is just like providing like a URL and a bunch of other inputs, and then that will just work out of the box. Monitoring. So basically, we make HAProxy log to a file using like rsyslogd, that kind of things, and we are reading that file. It means that we are not affected when we reload by counter reset, that kind of things. It's really easy for us to continue to read the files, whatever happens. And in that file, we can see a lot of different things. So when we look at one line of the file, you will see the client, the environments, also the partner, the environment, the application. And what's interesting is that when we change the URI, like when we want to send 10%, the example at 10 a.m. on a Sunday, actually the URI that you will find in the logs will be the original URL. So the URL that the application wanted to call. But the backend that you will see in the log is obviously the backend that was actually used. So you can see which request was done on which backend, even when you have those rules like the Sunday at 10 a.m. rule or the 10% to another service rule. So basically, the log line doesn't lie, and it shows the correct input. Then you see the status and the duration, which enable us to build like a dashboard with the red method, which means like we see the request, we see the errors, and we see the duration. So we can see when something is going wrong. What we are using is Prometheus. So we are big users of Prometheus, so we don't, regarding monitoring, we are quite up to date. We use Grafana, the HAProxy exporter, so we are still in 1.8, so we don't have the native metrics yet, and we use mtail. So just a word about mtail. So basically, mtail is enable us to do via all the logs that we get to do that kind of queries when you can see exactly for that partner, for that environment, for that target, what is the status. I have put on my GitHub page an example of mtail program. So mtail is a small program in Go made by Google that just passes log files and makes Prometheus metrics. This is very tied to our usage, and it's very flexible, so you can do a lot with that. And at the end, we have a full visibility on what's going on, which partner is failing, when a partner is failing, that kind of things, and we can do very precise alerting to know which application is failing now to talk to this partner. So sometimes it will be because of the application, sometimes because of the partner, and we have actually a really nice view on that thanks to this. So conclusion. So the configuration of Egress is now a very simple concept for the application maintainer, so they only know what they need to know. We have put very nice monitoring on top of it, so that we have actually some Grafana dashboard when you can just select, I want to see now the traffic for that application in that environment to that partner and that, so we can quickly dive into what's going on in the infrastructure. And we're actually using a lot of, well, advanced HAProxy feature. What I mean is that feature that you normally don't use with HAProxy, but that are really nice for some use cases like our use case. So now we have, like, we completely understand how our application will talk to the outside world. So we understand the timeouts, we understand how they will retype the TCP connection. We have detailed metrics, so that's very nice of HAProxy to provide us, like, in that connection, how much time did we spend connecting, or how much time did we spend sending the data. So all of that we now have, like, fully detailed reports, fully detailed metrics. We can now be quickly alert when something is not responding, when something is down. It means that when we need to change or when we need to analyze a failure at a partner, we know it directly. So we can directly see also the business impact. So maybe for a partner, just an application will not be able to talk to one service at the partner. We see it directly now. We see it at the HAProxy level, and we don't need to look at different places. So HAProxy will just, like, centralize all that thing. It also means that a very 20 years old application will also talk TLS 1.2 now, which means that we are not blocking partners to, like, make their TLS stack evolve. And we are just very happy to say, okay, yeah, we will support TLS 1.2, we will support SNI. Yeah, just do whatever you want. We will not block you. It also means that the timeouts are unified across all the stacks, and the TCP retries as well are just unified. And also the two-way SSL is now delegated to HAProxy. So it means that when we need to upgrade a client certificate, we do it just on the HAProxy cluster and not on 4 different applications in 5 different VLANs, that kind of things. It does not happen anymore because we delegate that to HAProxy itself. And all that nice stuff that, so that we don't need to work on Sunday morning and that we can do kind of releases, that kind of thing is really, really nice and really helpful in HAProxy, so we really like it. And it also means that when we want to change something, we can usually do it when you want to change a URL, when you want to change something. We don't need to restart the applications anymore. So you can imagine that when you have a 20-year-old application that you need to restart it, like, multiple times to change or to tune a URL, and usually you want to avoid that. So basically, it's really helpful for us to just being able for those legacy applications to say, yeah, if we need to change some egress configuration, we can just do it at the HAProxy level, and then maybe if that's needed, we can change the configuration properly at the application side. But just being able to do it at the HAProxy level only prevents us to doing a restart of those very old applications. So thank you. I will now take the questions.
Thank you so much.
You're welcome.